Greetings, my name is Aleksandr and I present to you a paper called Personalized Travel Route Generation for Mobile Application. Despite a recent decline in all ways of transportation, overall, tourism is a booming trend that has a prominent economic potential and influence on the development and improvement of public services in various regions. As IT adds to tourism value, there is increasingly more technologies each year which aim to magnify the attractiveness of places of interest and develop a personalized approach to the creation of tourist routes. In this work, we propose a road generation system for historical cities using St. Petersburg as an example. E-tourism is a prominent field that has been actively developed in the last decade. However, the creation of such systems is still a challenging task as they should combine multiple points of interest in one trip, taking into account many constraints. Consider cultural and historical background of the cities and locations. Be relevant for user, create individualized experience, and last but not least, it should be user-friendly and convenient to use. Possible solutions include Pareto optimization heuristics with non-dominated sorting, multi-criteria optimization by popularity, cost, and number of attractions, road locations grouping using clusterization methods that take user ratings and feedback into consideration, genetic algorithm for variable neighborhood search and mimetic search in differential evolution, motivation-based routes matching with existing tourism topologies, Cummins clustering, tree-body with recommendations based on user web surfing behavior, and more. Despite each of before mentioned algorithms' effectiveness in solving small tasks on its own, without complementary components, they lack integrity and ability to work in larger perspective. To address these issues, we propose the full scope system, which consists of the following components: tool for valuable data collection, server for data storage and business logic, route generation algorithm for personalized route creation, and mobile application that serves routes for end user. In St. Petersburg, the history of city and its locations are inextricably connected to individuals who live there. That's why it's valuable to know the relations between locations and persons. To create the dataset of relations, the Wikipedia website was used. In total, the 15 gigabytes of data was downloaded, containing 84,000 locations and persons linked to the city. Then we applied a few steps of raw data processing. The first one is scoring. We calculated rating for each entity based on 7 criteria. It includes size of Wikipedia page, languages count that this page is translated to, hyperlinks amount, amount of external Wikipedia services URLs, count of word St. Petersburg and its forms mentioned in the text, amount of categories Wikipedia page belongs to, amount of additional notes, links and footnotes. The second step was filtering. We removed around 10% of persons from the list tail who had the lowest score. Frequently, these were empty pages with a few sentences in description and empty main body of the page. After applying filtration, only 81,000 entities left. The last step was transformation. We extracted the information from remaining entities: credential, birth, death dates, and description from persons, latitude, longitude, address, description for each location. In addition, each entity was associated with a characterizing set of tags, which also could represent relations between different entities. These tags were created with aid of natural language processing techniques, such as lemmatization and named entity recognition. For example, famous Russian poet Pushkin have tags: poet, literature, golden age of Russian poetry, Tsarskое Selo Lyceum, while Hermitage have tags such as museum, palace, sculpture, art, Catherine the Great, and much more. On this slide, you can see diagrams with distribution of collected persons along most popular categories. This information could give meaningful insights, which further could help with development of recommendation system. For this component, the following tools are used: Python 3.7 Re library for text manipulation, Requests library for data loading, Pymorphy for lemmatization, and Natasha library for named entity recognition. The next component is backend server. It is used for consistent data storage, row generation algorithm hosting, and mobile application serving. On this slide, you can see part of the data structure related to this paper. Row's recommendation algorithm is the core of proposed system. On this slide, you can see listing of pseudocode for our algorithm. It gives high-level overview without diving too much into technical details. The algorithm accepts following data as an input: user latitude and longitude, which is retrieved from mobile application; user profile of interest, which is extracted from social media and from search history and further transformed into a set of tags; input tags user is searching for example, Dostoevsky or museums; desired duration of walk; and lastly, database filled with data collected on previous step. First, algorithm collects near expert created rows based on their center of mass and tags specified. Then it uses the same user geolocation and tags to retrieve a list of nearest locations. The list of locations is further transformed into a list of optimal possible routes between each location. Optimization is done by calling Google Maps API. Each expert route is transformed into subset of routes by excluding different locations to match duration expected. The next step is filtering both the expert and generated routes. This operation involves the following procedures: rating calculation for each route in the subset of routes based on text relevance and location value; searching for most rated road in each subset, and lastly, exclusion of all roads in each subset except in the most rated ones. At the end of pipeline, the algorithm returns optimal route for a given set of criteria. For users, it means that they would receive unique routes tailored to their preferences and needs. This server was built using following tools: Mongo database for data storage, GraphQL for queries, Google Maps API for spatial and temporal information, Python 3.7 with Django for server core, and PyTest, MyPy, and Flake 8 for quality assurance. Mobile application is another important part of proposed system. It was developed bearing best UI practices and efficiency in mind. The application could authorize the user, display the list of nearby roads, display the list of recommended routes based on a keyword and duration entered by the user, display the chosen route description, show the user location and connected route points on the map, navigate the user on the route chosen, and save the route to personal account. This functionality provides the user with all necessary tools to have a tour desired in just a few clicks. In development process, we used React Native and sub-packages to create cross-platform application working on both Android and iOS. Apollo GraphQL was used to make requests to server, while Redux helped to manage application state. In the end, the new intellectual system for walking road generation and recommendation has been proposed and implemented. The system can provide an extensive set of possible routes for St. Petersburg as it considers durational, spatial, and historical information, as well as user preferences.